My name is Tessa Rogers, and this is my Chapter 18 presentation on proof of concept models. Let's first begin with models themselves. They're the embodiment of ideas and designs. I have a few examples over here. They are invaluable for problem solving at all stages of the engineering design process. And they're easier to understand, evaluate, and react to than abstract ideas. They're tangible. Then there's also several categories of models, proof of concept being the first one here. So proof of concept model or proof of principle model, they are, it's a real specimen whose purpose is to show the viability of an idea or method. They are frequently used by inventors, and some other fields that they're used in are clinical drug development in testing the effectiveness and safety. We've experienced a lot of that as of late. And then also in filmmaking, they talked about testing out the concept of the blue screen before making a movie. When it comes to the proof of concept models, there's a few different things to keep in mind. First, they're small. Another one is they keep them simple when possible. And then it could also represent a portion of an overall concept. So they use the example in the book of the brake on a bicycle being just a portion of an overall concept that you could use for a proof of concept model. And they verify the potential of a design. They're also used in what's called technical showstoppers. So these, this is when engineers see if there is anything that would prevent the design, the process, or the solution. So an example of that technical showstopper might be that they're designing a spacecraft to carry people into space, and one of the showstoppers would be, can the astronauts be brought back safely? So they would design a proof of concept model to test that. Proof of concept model in engineering, here's the example that I enjoyed in the book. This was in World War II aircraft carriers. They wanted the Navy aircraft to be able to stow the airplanes more efficiently on or below the decks. So an engineer at this company used paper clips and pink erasers to show how if they designed the wings to pivot, that they could be folded back on top of the airplane, similar to how birds and beetles fold their wings back. Then I have my classroom application. The first one would be simply math problems. So if you have a more difficult solution to get to, we may be able to work with students on finding a simple problem to get to the more difficult solution. So I have 6,000 times 5, and then they might be able to simplify that as 6 times 5, and then work their way from there. I also thought this was a really good concept to use in STEM projects. So for example, my balloon cars, I thought in order to represent a portion of the overall concept, that maybe we could use this in just the concept of the attaching the balloon to the straw effectively, having the wheel and axle move effectively. And then I also looked at the project that we're going to be working on soon for catapults in my simple machine unit. And I always thought of it as one long-range project with one creation, but I never thought about it with a small and simple model with a proof of concept model and then scaling it up from there to a bigger model. So in conclusion, proof of concept models are done early on in the design process, and they are used to demonstrate the feasibility. They're as simple as possible, and small as well. And then some of the goals also would be that they're low cost and the expediency, so they're done quickly. And thank you very much. I'm looking forward to hearing your feedback.